Okay, I think we're live. Hello, everyone. Welcome to a crash course in Kedro. Uh, um, I'll just take you through the agenda today. So, what are we going to learn? We're going to understand what Kedro is, where we feel Kedro fits into the data science ecosystem. We're going to go through a worked example of how to sort of work with Kedro, but in PowerPoint world in this presentation. And then we'll stop for a few moments, maybe a short 5-minute break. And then what I'll do is I'll take you through a live coding session where I will be going through what we call the spaceflights tutorial. That's something that you can follow along at home or watch or watch just now on your own, or come back to this video later and follow along in your own pace. There'll also be several opportunities to do a little Q&A session. You'll see on every slide there is the Slido code that you can enter in. For anyone, before I get to the next bit, I'll talk about me. So I am Joel. I'm a product manager here at Quantum Black Labs. I actually don't work on Kedro anymore. I work on something else, another internal product, but I am a big fan of Kedro and still very keen to contribute to our open source efforts. I started my career as a data engineer, so I used to be a practitioner before moving on to the product side. I have a computer science background, and I've been a Kedro user for over 3 years when it was a sort of small internal project that people were playing around with, also right the way through till it is what it is today. If any of you have any questions during this process, please log on to slido.com and enter this code. This code is actually on pretty much all of the slides. So if you have any questions or forget this code, you can refer to it in all of the headers and the slides. We'll have some people from the team monitoring that, and I'll take momentary stops to get going. It'd be remiss for me not to do a hiring plug. Kedro is now an open source project as part of the Linux Foundation. Several of us at Quantum Black are core maintainers, as well as some people externally, which is exciting. But at Quantum Black, we are pretty much hiring for all roles all over the world. So that's a very enthusiastic, please get in touch. If any of you are in these locations or would like to work in these locations in these sorts of roles, you can scan that QR code, you can get in contact with me or via the page, and we'll be delighted to take you through that process. So I think a lot of us have seen data science that looks like this. It's a quick and dirty shack that was built for a single purpose. Some corners were maybe cut. It works as shelter. It ticks that functional requirement as it will protect you from the elements. Would it work long term? Maybe not. Were there any blueprints on how you got there? Definitely not. This analogy is a little bit strained, but you can see that when you're just trying to generate insights, this is fine. This is, we've all built notebooks that look like this. You can get to the answer you're looking for very quickly. And that's sometimes exactly right. But there is also a push that when you need to harden something, when you need to bring it to production, when you need to make it enterprise ready, the shack won't cut it. And there's often a temptation to use duct tape and find workarounds in the work that you do. This clock example is a little bit labored, but I'm a big fan of it. It does meet functional requirements. You can still read the time, but there was probably a lack of planning, forethought, testing, all other parts that went into the development of that time reading situation. And that's what Kedro is all about. It's trying to find that right balance between the rapid prototyping stage that's so core to machine learning and developing products in that space, and building robust software that we can stand behind. So fundamentally, rather than the shabby shack that we just saw a couple of slides ago, this is the future we're trying to build. This is well-designed enterprise-level software that has an ML component. It needs to be rerun, needs to be maintained, it needs to be traceable, needs to be very clear. And importantly, a team needs to build this. It can't be something that the pockets of knowledge live in certain people's heads. Some of the quotes popping up on screen, I hope, are pretty familiar. The phrase, everyone works in different ways, my code will not run on another person's machine. These are very common statements that you hear from teams that are working in the data science world. And Kedro looks to address this because actually we had that problem a few years ago at Quantum Black. Lots of clever people in different teams, all running code that looked very different. And there was best practice in pockets, but it was in people's heads. So the reason that we've tried to codify this as a framework is to allow that best practice to be used as a framing for the way that you build out ML products and data science work, whilst you maybe lose a little bit of flexibility in the way that you approach things. That limitation of the variation allows teams to be more intentional and purposeful in the bits that are really important, the actual modeling and machine learning. You don't have to spend all your time arguing over some of the things that are already solved, and you can get on with the hard bits that are really worth your time. So actually, what is Kedro? So Kedro is a Python framework designed for machine learning and data practitioners. A lot of its design philosophy comes from something called the 12-factor app. If you're not familiar, it was a team of Heroku engineers, if I'm not mistaken, who were very keen to document their ideas about how to build strong and robust web apps. What the original designers of Kedro took from that is how could we adapt a lot of that thinking to the data world? So core concepts such as modularity, separation of concerns, and versioning are just three of the ideas that are covered in the 12-factor app, which I thoroughly recommend you read. It's a short read, but it's very valuable. And you'll see that a lot of that thinking is built into Kedro, especially when it comes to how we separate our configuration from our business logic. Why do we think Kedro needs to exist? So there's a lot of debate about the value of Jupyter Notebooks. And I think, and this is a personal opinion, I think they are an incredible storytelling, communication, and prototyping tool. And I think that there's been amazing work to retrofit it into something a little bit more production scale. But when it comes down to it, I think Jupyter Notebooks struggle when you need teams to collaborate. You have to go through hoops to make it work well with version control. And fundamentally, we're of the opinion that whilst you should prototype in a notebook, you should build pipelines in an IDE where you have all of the advantages of a code editor that knows how to refactor things and run unit tests, etc. So you can really think of Kedro as a bit like React or Django for the ML world. You still have to build the app. No one's going to build the web. Django doesn't build the web app for you, but it provides you all of the framing so you can create your connections to the database and build your models and do that stuff very efficiently. And you can also hire a Django engineer who already knows how to work in that world. Same goes for React. So again, the benefits of Kedro mean that you can arrive on a Kedro project, any Kedro project, and know how to contribute and be useful immediately. And the last part I can personally attest to is that a lot of the ideas from Kedro really stem from our scar tissue for doing this for a long time. One of the very early naive mistakes I made was hard coding all my file paths in a pipeline. I will never make that mistake again, and it's something that's very difficult to do in Kedro because the way that we ask you to declare your inputs and outputs forces you to be declarative and dynamic. And you'll see more about that later. And Kedro has had quite an impact on the world of MLOps. We're quite proud of it. So it's covered in some of the landscape pieces run by First Mark Venture Capital Fund, as well as we've won a couple of awards. And I think that's slightly out of date. There's 6,600 stars on GitHub, which we're very proud of. If any of you are able to contribute to that number, I wouldn't be upset. But yes, it's been the reaction from the community, especially after this recent move to the Linux Foundation, has been just wonderful to see, and it's been great to be part of this journey over the last 3 years, going from an idea that a couple people had to something that's had such impact. So then we have to ask ourselves the question, what does Kedro actually give you? Out of the box, you get something very simple, which is a project template. And the very first version of Kedro was basically this. If you're not familiar, there's a wonderful library called Cookie Cutter Data Science. Much like the 12-factor app, I would thoroughly recommend you read their philosophy. A lot of their ideas and thinking is baked into Kedro, and we wholeheartedly agree. So one of the elements of Kedro, and you'll see this in the live demo, is that every Kedro project looks roughly the same. And what that means for teams, especially multiple teams within the same organization, means that you gain the superpower of being able to move people around. And that was super useful for us internally, because it used to be that if someone left a project or rotated onto a project, it would take 2 weeks to onboard them. And if you can skip that level of onboarding penalty, that's a real accelerator in some situations. So you get a project template, and I'm not going to complain that it does anything super unique there. It's just a consistent and we hope well thought out way to lay out your work. You also get what we call the data catalog. This is somewhat unique to Kedro, and you'll see how it plays downstream, but it's our way of declaring in a declarative way how to where your inputs and outputs should live in your project. So there are lots of ways to connect to different data sources in Python. You have the pandas read methods. You could be using Spark. You could be using Dask. And you can also have lots of ways that your team members address those. It can be via APIs. It could be via heavily string manipulated custom methods that people like using. The point about this is consistency. If we can move our teams to be using a common way of working, what you get is a really easy way of people collaborating and also making sure that things are addressed in a consistent way, in a shared way across the team. Hopefully this will make a little bit more sense as we go into the demo a bit later. And the next part is the nodes and pipelines. This is very common as a concept in the industry. There will be lots of tools, and I'm sure we'll get the question a bit later about how Kedro compares to something like Argo or Airflow. Nodes and pipelines aren't new. I think the only bit that's probably unique to Kedro or somewhat unique to Kedro is the fact that we're very data-centric rather than task-centric. So our nodes don't take responsibility for loading and saving data. That is delegated to Kedro and its data catalog. All the nodes and pipelines need to do is the transformation and string of and the topology, the execution order, is purely derived from the data flow that those nodes require. Again, big point, but it will make a little bit more sense later. And importantly, the nodes and pipelines are data-centric, not task-centric. There's also an added layer of extensibility that's core to Kedro. So all of our core library components can be inherited and extended as pure Python classes. That is super useful in a couple of places in particular. So the first of which is being any of our data sets. It's very easy to take one of the ones that we've battle tested and extend it for your purposes. It's also easy to create your own ones. And that's how we end up with awesome community contributions like a GeoPandas or a bioinformatics data set that's niche to some users in that industry. So it's as a common pattern for extending our I/O reading and writing capabilities, and an easy way to extend Kedro for your benefits. We also have something called hooks, which we took using a library made by the PyTest folks called Pluggy, that allows you to extend any part of the Kedro run lifecycle. So as pipelines are running, you can do things like log metrics or time how long execution is taking, or I've even seen some clever things with data version control being connected. So there's a really nice way of you adding extensible parts to Kedro without really changing the library itself or having to go deep into our code. There are nice little entry points made for you. And then there's also a full plugin architecture so that if you need to do something more involved, this is where we see a lot of our open source integrations emerge. So a wonderful community developed Kedro ML Flow plugin works this way. Same with the Kedro Dolt. There's a few others, and that's a more involved way of integrating with Kedro, but that's the way we see our open source users really start sister and sibling projects. And inevitably, we answer this question a lot, but it's a really subtle difference and it's worth spending some time on. In the journey to production, Kedro's zone of influence is the bit in green. We are there to help you build the finished article. In terms of executing and deploying the finished article in something like Airflow and Prefect, it's doable in those tools, but they're very much designed with executing in production in mind, which makes sometimes the rapid prototyping and experimentation workflow quite difficult to manage. So hopefully, as you'll see as we go through this training, Kedro allows you to, as a team, get through this pretty consistent process of building models and making sure that they're fit for purpose before you can leave Kedro and run in something else. And that's very much the pattern that we want to encourage, and happy to answer more questions on the topic via Slido when we get to the end of these few moments. So today, Kedro is used in purely open source contexts at these companies. Obviously, when it was a not entirely Linux Foundation project, there were many other organizations that use Kedro as part of Quantum Black's consulting engagements, but all of these people have found it on their own or have written about it in the public, and it's been really exciting to see organizations, especially ones like NASA, using it to make sense of their data science workflow and really, that especially when we saw NASA, we were high-fiving in the office. That was a huge moment for us. So in terms of official support, there are three main avenues that we track. So our documentation, people like myself spend a lot of time making sure that's accurate where it can be and up to date. So the Read the Docs site is our Bible for many things. There is also the Discord channel, Discord server, where we hang out and can also answer interactive questions, and there's a little bit of a community growing there, so nice to see so many people get involved. And then GitHub is increasingly our main hub for everything else. So as we've moved to the Linux Foundation, more and more of our development processes are becoming open-facing. So as the backlog features and everything else there increase, pretty much all of our development decisions are going to be open. But for now, things like feature requests, our version control of our code, bug reports, discussions, and all sorts of good stuff happens there. And that is a great way to get involved in the open source efforts. Last thing to mention is Kedroid at the top right. That's our little character for people that get involved with the community and help each other out. If you do happen to do that, there is a very good chance we'll send you some stickers or a hoodie or something like that. So always the temptation to be a Kedroid should be high, and we encourage you to become one. So in this next section, I'm going to take you through what actually building a pipeline looks like in practice. So let's look at this pipeline on the left. This pipeline was actually visualized with Kedro Viz. You can play around with a pipeline yourself at demo.kedro.org. And Kedro Viz is our internal first-party plugin for visualizing Kedro pipelines. And we'll go through that together later. So on the left-hand side, you'll see that we're taking some data, companies, reviews, and shuttles. And we're going through a pretty standard transformation process to build some metrics. Let's set the scene. The year is 2160. Essentially, we have some space shuttle companies that are taking tourists to the moon and back, and we have some reviews from customers who have done the space travel, and we want to basically estimate the price for a return trip. It's a pretty simple problem, but it's one that we use to frame many of the parts of the journey that a new Kedro user go through. As I said, there are 3 raw data sets. The company's data, these are the players in the travel industry, the reviews from customers, and the metadata about the shuttles themselves, so what their fleets look like. We have 2 nodes at this stage where we take the company and shuttle data and pre-process that so that we can use that data neatly and in a typed format in our next stage. Nodes in Kedro are pure Python functions, i.e. ones that have no side effects. We can talk about what that means a little bit later. Here, their purpose is purely to clean the data ready for downstream joining. Those 2 pre-processing steps are also saved as new data sets in a typed format, something like Parquet, as we go through the process. We then are able to create a new model input table that is derived from the 2 pre-processed data sets, as well as the reviews data set that, for whatever reason, is ready to skip straight to that stage. This is the problem we're going to go through today. So, on the right-hand side, you now see some YAML, and that is from our data catalog. So there is a YAML API that we expose for users to document their data sets. And these are for things that we want people to share across a team so that you can reuse them and understand what someone else that you're collaborating with has done. All data sets have a unique key. So in this situation, companies and shuttles. They have a type. And this can cover all manner of things, but today we're going to look at some pandas ones. They have a location. And the layer element we actually didn't need to include, but is a visualization constraint where we can make sure that nodes stay at a certain level of the topology as they progress downstream. The shuttle's data, you'll notice, isn't CSV, it is Excel. Behind the scenes, we're just calling pandas.readExcel in this situation. And that is a philosophy in Kedro that our data sets are very thin wrappers to the underlying API. You also notice that this file path isn't local, it's S3. And that's because we use a really handy library behind the scenes called FSspec that is maintained by the Anaconda folks. And that abstracts all file systems so that you can use everything from Google Cloud Platform to Azure to SSH to Databricks. And it makes it really easy to stop worrying about where your data lives and just declaratively say, I want this and I'm going to do that. Kedro also has lots of handy connectors that are useful for visualization or network analysis or saving Python objects via various pickle backends. There's a lot of flexibility into how you do I/O in Kedro. And if it's missing, it's very easy to define your own. And we'd always appreciate a PR back into the main project if it's something useful that you think others would benefit from. You'll also notice that over time, you want to avoid rewriting that much YAML. So there are a couple of templating styles that you can use. Personally, and there's a little bit of debate in the team on this one, I'm of the opinion that explicit is better than implicit, but it is also annoying finding and replacing when everything's in YAML. So there are a couple of mechanisms to, say, declare your S3 bucket in one place and reuse it in all sorts of places over and over again. There is also, and we won't go into it today, but it's something that I'd encourage you to read up on if you think it's valid. There's a way of following the 12-factor app philosophy of having something called configuration environments. So you can essentially have a mirror globals.yaml in our production folder and a staging folder. And what that would do is it would swap out the S3 bucket depending on which run mode you were in. And that becomes a really nice way of separating your concerns and not making sure that you had two different parallel pipelines that did the same thing in two different locations. We also support Ginger 2 style templating. again, a little bit of debate in the team of how imperative we like our declarative YAML to get, but it is supported because a lot of users do want it. So let's actually go through this part of the pipeline. You see there's a little f to say that it's a function. These are our nodes. And our nodes are bound to a pure Python function. And the one that we're bound to on the right-hand side is here, preprocessed companies. You'll see that that accepts a data frame. Actually, there's a bad type hint there. I need to fix that. It accepts a data frame. It adds a percentage column, and it returns a new data frame. It uses a private function above as well. But importantly, you'll notice that function has no responsibility for where the data passed to it lives or where the data passed out of it needs to be saved. It is purely interested with doing the transformation. And that's really beneficial for a couple of points because it means that writing unit tests for this is very simple. You don't have to mock any I/O. You can purely give it a fake data frame, ensure that the percentage column is valid, and then you're happy to reuse that over and over again. Again, this may be reiterating that point of Kedro isn't doing anything that's rocket science. What it's doing is maybe limiting you to work in a little bit of a way. That means that you can follow best practice and focus on the important part, which is the actual content of the node rather than how it reads and writes data. A collection of nodes can be passed to a pipeline object. And in the next stage, we'll understand how this entire process is articulated in pipelines.py. So you'll see that there's actually 3 nodes here. The first one is the preprocessed companies node that accepts the company's data and outputs the preprocessed company's data. The second one does a mirror operation for the shuttles data. And the final one accepts the 2 preprocessed outputs and then joins that with the raw reviews data to create a model input table. So essentially, this node syntax allows you to bind to a Python function, pass inputs and outputs that are declared in the catalog, and derive a pipeline by passing a collection of these nodes to the pipeline object. You'll notice that all of these nodes are linked to a function, and they all have inputs and outputs. And one thing to emphasize, and I appreciate there's a lot on screen here, the green ones are declared explicitly. So companies, shuttles, and reviews must exist at the beginning of your pipeline, otherwise it wouldn't know what to read. The model input table is something that could be written as a result of your pipeline. But if you notice, preprocessed companies and preprocessed shuttles aren't actually declared in the catalog. They're addressed in the pipeline logic. But what that is a special bit of Kedro that I really want to highlight, is that we have a concept called the memory dataset. And that's essentially an ephemeral dataset that only exists at runtime and can be used to pass data between nodes. And at the point that the pipeline is no longer needed, they're thrown away. There's a couple of benefits for doing this. The first of which is you don't have an I/O penalty. You don't spend any time writing to disk. And the other point is what we see is a very common development pattern in Kedro is while you're building things up, you declare everything. You always have a checkpoint that you can start a pipeline run back from and make sure that it's working at every stage. But once you're happy with what you're building and you've got close to the finished article, you can essentially throw away the catalog entries for everything intermediate and just start with the bit at the beginning and the bit at the end. And that's the only stuff that actually has to get written anywhere. Everything else can live in memory, be a lot faster to process, and you can start thinking of pipelines as purely inputs and outputs, not really intermediate steps. The last thing to cover before we take a break and maybe look at some questions. You'll see the pipeline definition on the right and the pipeline visualization on the left And in many situations, the order in which the human provides the pipeline definition drives the execution order on the left. One thing to emphasize is in Kedro, that is not what drives the pipeline topology. Kedro basically looks at the data that is required at each stage of the pipeline and does a topological sort. So that means that it is really irrelevant on how the human has added the data to the pipeline or what order the nodes are passed to the pipeline object. The only thing that matters is that at the very end, we have to make a model input table. So Kedro looks at the right-hand side and sorts it for you. And this is maybe one point where I want to highlight the benefit of thinking in a data-centric way, is that you're no longer thinking about how data will be read and saved. You're also not thinking about what order tasks have to be scheduled. All you're thinking about is, I want to do this, and then output that, and then reuse that output in something else. And you string together your pipelines in a what we feel is a much more closer analogy to the way that you think. So this topological sorting is a really powerful part of Kedro and something worth emphasizing at this point. So we've actually come to the end of the slides. That took us about half hour. At this point, we're done with that content, and we will take a short break and then jump into the live coding session. I'm going to quickly jump to Slido and see if any questions are there that are... Oh, we've got lots of questions. So let me stop sharing that screen and go to the other one. So, okay. Sorry for the delay on that one. Just bring up the slides now. Excellent. So, very good question of Kedro. Can it be used with conjunction of MLflow? So there's actually two ways that this can work. There is a wonderful open source plugin called Kedro MLflow. It is not maintained by the Kedro team explicitly, but the maintainers do hang out on our Discord. It's well supported and well used, and it can get you going very quickly. We also, in our hooks documentation, our we have a quick and easy integration that we document how to do that via our lifecycle management plugin mechanism. It's also worth highlighting that there's a couple of other experiment tracking mechanisms in Kedro. So there is also Kedro Neptune, which is made by another experiment tracking company called Neptune AI, who the team met recently. So that's available if it's interesting to you. There is also a relatively new native experiment tracking mechanism built into Kedro itself. So that's something that isn't necessarily designed to be a full-fledged competitor to MLflow. It's basically giving you experiment tracking with zero infrastructure. If you go to demo.kedro.org and go to the little lab beaker symbol, you can have a look what that looks like in a example. So what does Kedro's view in terms of large data sets that do not fit into primary memory? Is there any plan for a video data set? Ooh, good question. So large data sets are handled a couple of different ways. We have native integration with Spark and things like Dask. So if you want to do your execution in a remote way, that's possible. For image data sets, we actually have a abstraction called the incremental data set and the partition data set that allow you to take certain parts of a data set and only read the bit that you need. I've also seen people take some of the PyTorch abstractions, write a Kedro wrapper for that, and then it's able to use very quickly. To my knowledge, there isn't a video data set built in, but there's no reason that you couldn't take the demo partitioned image data set that we have in the docs and simply change that to work with video data, or potentially take the split the video into images and just use the default image processing. What are the Kedro alternatives which are most used, and what are the advantages of Kedro? Big question. I hope some of those points were highlighted in the slides. The biggest competitors to Kedro are a bit of a difficult one. So there's a whole world of orchestration. So things like Airflow, Dagster, and Argo, which are task-centric, very good tools at doing things like scheduling and monitoring and retries and things that work really well in production. As I tried to articulate a bit earlier, Kedro is designed for the journey up until that point, and then is designed to integrate really neatly with those tools. So there's a native Kedro Airflow plugin. There's some good talks that you can look on YouTube of how people have used that. There's also a third-party open source Kedro Argo plugin. So that journey to getting into the orchestration stage is something that we are trying to solve via an integration rather than do ourselves. In terms of what I'm mostly, it's a bit funny. There aren't many pipeline authoring frameworks. Personally, I think there's a lot of similarities between the way that Kedro is designed and the way something like DBT in the SQL world is designed. It is also data-centric and tries to be very declarative in the way that it works. Big fan of that project. And I think for a lot of the data engineering workflow, DBT is a very, very good tool and can transition straight into Kedro, reading from a SQL database into the bit that needs to live into Python. That's the way that I kind of imagine Kedro in the modern data stack working. Dataiku is a very good tool. There's also been a couple of attempts by some open source users to write something that converts from Kedro to Dataiku. I'm not a massive expert on it. It's something that is available for big enterprises. So it's something that is not necessarily accessible to all people. So I guess one of the advantages of Kedro is that you need zero infrastructure to get up and running. I might be wrong on this, but my understanding that Dataiku also has this sort of visual development paradigm. That is something that Kedro doesn't do. I'm not sure it will ever do, and is more IDE up. So it's possibly starting at a higher level of software engineering rigor. Again, that's a personal opinion with someone who's never used it, but that's kind of my understanding. Happy to answer more questions on that, maybe on Discord after, if we have more detailed conversation. Is ML deployment the only use case of Kedro? No. So Kedro is just a mechanism at its core of flexibly asking for data, doing some work, and pushing data out. That doesn't need any ML. What we did recognize when Kedro started is that internally we had lots of very clever data scientists from all sorts of walks of life. But it would be fair to say that the level of software engineering wasn't necessarily consistent across the board. So what I would say is that there's a drive in Kedro to enforce some ideas of best tracking, to make best practice, to make sure that your code is well tested, to organize in the right way, readable, built in an IDE, all of these things that are very clear from the software engineering world, but maybe not necessarily common in the machine learning world. So hopefully you'll see that a lot of the design decisions are targeted at typical ML users, but there's no reason to say that that's especially ML required. Yes, quick answer to that one, yes. I will say that the Databricks documentation is slightly out of date. They are currently in a transition period where they've deprecated something called Databricks Connect, which is a way of using an IDE with Databricks. They are launching a new, more secure version of that, but we're in a period where that it's not released yet. So the minute that goes released, we will update our docs so that you can use Databricks from an IDE with Kedro. As far as I see, nodes wrap functions, but the nodes themselves have different signatures. It's possible to help the IDE flag signature mismatches. There have been a couple of attempts at this. It's something that we're still looking at. At the moment, no. You sort of reference the catalog key as a string. It's a fair point. It's not something that's very well explored at this point. MLflow API has become very standard. I would say that there's a couple of points about needing some infrastructure to get up and running. So we know that's a pain point in some organizations. We also wanted to have a native visualization in Kedro Viz. And we also struggled to map our idea of a Kedro run to an MLflow experiment. And those two didn't necessarily align in the way that we thought about things. That being said, one of the advantages of us introducing our own experiment tracking mechanism for at least declaring these things means that we now have a common way to build integrations. So there's a small subtle point, and maybe it's not the right time to get into it, but by just doing a logging call imperatively in your Python code, it's not necessarily easy to do that in a pure function. So we went down a route where everything is a pure function and is done via data sets. And then potentially if everyone wants to migrate our MLflow integration via that way, it's very doable. I'm going to stop there. I'm going to take a 5-minute break and maybe everyone join back at sort of a couple of minutes until 10 to the hour. So 5:48 my time, which is a random time. Maybe let's call it 5:50, 10 to my time. So thank you everyone for joining so far. I'm going to take a short break and then we'll jump into the coding section of the demo after that. Okay, I think I'm back. Cool, thank you for sticking with me. I'm going to now go through what we call the spaceflight tutorial. On the right-hand side, I'm in mobile mode, handily going to be walking through our tutorial. On the left-hand side, I've got VS Code open, and we'll follow things from there. You'll recognize that the scenario is exactly the same as it was in the demo, and you can follow along at home, but I'll be working through and sort of trying to highlight some of the important parts of Kedro as we go through. I'm in a fresh virtual environment that I created just before this called Kedro Tutorial. If I do pip freeze, see, there is not much in my environment, just the certificate library. So let me pip install Pedro. Is the easiest part of the process. It will install Kedro 17.7, which was handily released yesterday with a couple of nice little features. We'll just wait a couple of moments for it to think. Work through regular Python packaging pieces. And you'll have a look that actually things like pandas aren't a requirement of Kedro. We try to ship the smallest version of Kedro as possible, and if you need to read things like pandas, that will come later. So hopefully that will make sense as we work through this process. I'm just going to make this a little bit bigger. Okay, so we're going to create a new project. We're going to set up the data. We're going to create a pipeline, and we may get to the package process. What I'm going to do is I'm going to cd into my documents, my projects, and I'm going to make a folder called training, cd into training. And if you notice now, I can type the word Kedro. That's new after just installing Kedro, and there's a few commands that are available to me, global commands. So I can bring up the docs, which is the things on the right, read about Kedro. There's something called Kedro starters, which we aren't going to go into today, but if you ever want a fully up-to-date Kedro project, you can then use Kedro starter to pull that and get a working project. That's quite exciting because whilst this process allows you to build the Kedro spaceflight tutorial from scratch, what you can do is this, and you can get the finished article for you. I'm not going to do that today, but Kedro starters are a great way of getting to the end. And what we also encourage is for organizations to create their own internal starters. So you can get a template that works for your teams, and then every project can be customized to your own example. And we have a lot of feedback that people in big organizations are doing that to roll out to their teams. Okay, so what are we going to do? We're in our folder. There's nothing in it. If I do Kedro new, and I call this Kedro tutorial, I'm going to give it the same repository name and the same package name. In the future, I think we're only going to ask you one question, but for now you get three. And if I look at that, I have a new directory in there. And if I type the word tree, you can see the folder structure has been built for me. What I'm going to do is also, I'm going to open VS Code at that directory. Get a new VS Code here. You'll see that it is already opened at the Kedro tutorial. I've got my project structure. And if you give me a second to add the right Python library, so select interpreter, Kedro tutorial. Now, when I open a terminal, it is activating the right virtual environment, and I'm ready to go. You'll see I have my source folder, and I have a package called Kedro tutorial, and I have some example files and an example pipeline ready to go. I also store my catalog in the base folder. Something we didn't talk about in the presentation element of this training is that the base folder is committed to Git. So your team sees everything here. Your local folder is only for you. And we have a special mechanism that if anything has the same key in local as it does in base, local wins. So that means that you can have maybe an overriding password or an overriding catalog entry if you decide to declare it twice, but in different levels. That's something we can come back to. The other thing I'm going to do is I'm going to initialize this as a Git repository, and I'm going to add everything for a first commit. Yes. Init commit. The reason I've done that is now anytime I change something, you can see that I've added some lines. This file will change to yellow. So you'll basically see what I've done from the base template going forward. So we basically have now started from scratch. I've got an initial Git repository. I'm not going to set up a remote. I don't think it's necessary, but hopefully you understand the reasonings behind that. So I've done this stage. You'll notice that we have a requirements.txt. So whilst Kedro is a dependency, all of this stuff we need in our project. So I'm going to install the dependencies by actually tweaking this for a second and putting a couple of extra dependencies in for my purposes. So I'm installing, and you can see these lines have changed. I'm installing Kedro, but I'm installing these explicit dependencies, the CSV dataset, the Excel dataset, and the Parquet dataset. I'm also installing Kedro Viz, which will be useful later. And then these two are needed for the data engineering and data science processes. So OpenPyXL is a more modern version of the Excel dataset. We will be making it the native one in the future, but at the moment it's an optional dependency. And we're on to modern version of scikit-learn. Now, if I copy this line, and Python will do its thing, and it will install the dependencies that are declared in requirements.txt. That little warning is because we've had to make a special case to handle Python 3.6, but we will be dropping 3.6 support in the next major version of Kedro, which is due out shortly. It's also no longer receiving security updates from the Python Software Foundation, so I think that's a good enough reason for us to not worry about it as well. So give that a second. And we'll be ready to do the next bit, which is set up the data. You'll notice that in the data folder, we have some empty folders that are set up to describe how we think data should flow through Kedro. This is actually very much inspired by what's in cookie cutter data science, and you're free to change this, but it's an example that your teams can follow. There's also a long Medium article about why we settled on this structure, if you're ever interested in reading, that you can find. I think it's called Layered Thinking in Kedro. But what we'll do is we'll start putting some data in the raw folder. In practice, we actually encourage you to store data in the cloud. Doesn't make sense to store locally, especially if it's sensitive. But for the purposes of this demo, we'll put it there just to get up and running. Once it's finished installing, I'm going to run these 3 curl commands to actually pull some sample data from GitHub into our environment. And just let Python finish doing its thing. Or actually, I can cheat, and whilst it's doing its thing, do the curl commands. Okay, and you'll see in the raw folder, I now have 3 data sets, which VS Code is marked gray. So by default, Kedro also handily makes sure that none of this stuff gets committed to Git, because you don't want to share data. It's one of those things where Kedro is a little bit opinionated, but with good reason here, we're keen that you don't unknowingly leak anything to version control. Okay, still waiting for this to finish. Cool. So whilst that's still finishing, we can start setting up our catalog.yaml. There's a link to the documentation here if you ever want to learn how to do this properly or in a lot of detail. But what we're going to do is we're going to declare our first two CSV datasets. Okay. I'm just going to double check if Kedro is working. Okay, so here's a good time to actually talk about something else. If I go up one level and I type the word Kedro, you'll see that I only get give it a second to load. Yeah, close both of these. Okay. So the level above Kedro tutorial, if I type Kedro, you'll notice I only get these global commands, docs, info, new starter, and this viz command, which is a plugin because we've installed Kedro viz in the previous step. If I go into Kedro tutorial, you'll notice that I get all sorts of other Kedro commands because I'm in project mode. I'm going to opt out of telemetry. As a product manager, please opt into telemetry. We don't track anything that's useful and we or project specific. We basically want to understand what commands you're using so we know which bits of Kedro are most useful. But when you do run Kedro within a project, you'll notice we get project specific commands. And this gives you all sorts of stuff that we want to encourage users to do. So we have like built-in linting and catalog reading commands and stripping all outputs from Jupyter notebooks. But the first thing we're going to do is I'm going to load up, excuse me, I'm going to load up an Kedro Ipython session. And what this is it's a regular Ipython session with the Kedro catalog available as a Python object. Okay, and you'll see that there's some global variables here: context, session, catalog, and pipelines. If I do catalog, you'll see that I get a catalog object, and I do catalog.list. I have two data sets that are available and this special parameter type, which we can come back to. If I do catalog.load companies, you'll see that we have abstracted the pd.readCSV method, and you're able to get that data as a data frame in memory and play around with it. The point we're trying to show is that by just doing these two lines in our catalog.yaml, you can use the Yaml API to declare things in a consistent way, and you forget ever having to like do this operation inside your nodes. Your nodes no longer take responsibility for I/O. It's also worth showing that we have a couple of other things that I don't think we cover in this, but if I was to do that, for example, what that would do is it would pass custom arguments to the pd.readCSV method, and you can apply any of the fancy things in the Pandas API if you want to. The same goes for save args as well. I'm going to exit Ipython. I'm going to add this last. I'll just copy it from there. And what this will give us is the shuttles data, which is an Excel data set, which is at a different path and uses a custom argument to the pandas.readExcel method, which is to use the modern Excel engine. And as I said, we're going to drop support for the old XLRD engine shortly. If you want to look at the docs, you can jump here. And in the pandas documentation, essentially any of the arguments that are declared here, if you wanted to provide them to the underlying pandas Excel reader, you would just put them under load args. If you wanted to do the same to the Excel writer, the same thing goes with save args. If you wanted to go into Ipython mode, you could load shuttles this way and have a look at it. The last thing to reference is if you want to make your own data set, we have lots of documentation on how to define your custom data sets. It's a great way to become an open source contributor, which is always good for CVs. We're always looking for that. Okay, so we've added some data. Let's make a pipeline. So our pipeline logic is different from our configuration logic. We call a pipeline logic business logic. It's something that has to live in source code, not configuration, following our 12-factor app policies. Now you'll look that this pipeline folder is empty. You can just create your own folder structure and start stringing it together using Kedro objects, but we really encourage you to use Kedro CLI to build this stuff. So if you do Kedro pipeline create and you give it a name, you'll see that it makes, and it's all gone green because it's new in PyCharm, it will make a nice little folder structure, a README for you to declare to document this to other users. It will also do the stuff that no one likes doing, like making sure your init.pys are in the right place. And it'll give you some boilerplate for your pipelines and nodes. Again, you are completely free to do this yourself. You don't need to build the folder structure using the CLI command. But one of the reasons to do so is that Kedro builds it in a certain way that it is what we call micro-packageable. And this is an advanced use that you would have to read up in your own time. But Kedro now supports a way of pulling source code out of projects and pulling it pushing it into other projects. So as an organization, you can reuse the same pipelines across teams. And that's a real superpower that people gain from using Kedro. Okay, this is a little example of what that folder structure looks like. You'll also notice in the tests, we've actually made some pipeline-specific tests that follow the right convention for PyTest to pick up and match to the structure that we've just created. The first thing we're going to do is we're going to copy some logic from the nodes.py. Okay. I'm going to go down a level of zoom, and we'll just quickly talk about what this is doing. We have a preprocess companies method, which accepts a data frame and spits out a data frame, and it mutates these two columns by converting this from a string column to a Boolean column, and this from a string column to a floating point column after it stripped the percentage character. The preprocess shuttles project does the preprocess shuttles function does a very similar operation, and it will clean up this data and make sure that it is ready in the correct types. Okay. Now in the pipeline.py, I'm going to overwrite the boilerplate and put this in here. You'll notice VS Code can't see these, so let's import them and do the same thing there. Okay, so what do we have now? We have a pipeline file and a nodes file. The nodes themselves only take responsibility for transformations. The pipeline, if I open the catalog to the right, you can see that the pipeline references this company's dataset and this shuttle's dataset, and it outputs preprocess shuttles and preprocess companies, which are going to be memory datasets because there's no catalog entry to find it. We can come back to that in a second. You also note I got this error saying you need to register this pipeline. So what does that mean? in the pipeline registry command, pipeline registry file, and this is where all of your core pipelines are registered. I'm going to actually copy and paste from here. What this will do is it will import our pipeline, which is its whole Python package, as DP. The DP object has a create pipeline method, which we store in the default Kedro run key. You can also explicitly call it by doing Kedro run -- pipeline DP. But we'll come back to that in a bit. What I want to do here is, because in the pipeline definition, we've explicitly given this a name, what you can do is this. You can say Kedro run -- node preprocess companies node. The output is a little bit hard to read when I'm zoomed in this much, but what you can see is it found the company's CSV, it did the node, and then it's saving data to a memory data set, which, as we know from the tutorial before, that's an ephemeral object that only exists at runtime. By the time Kedro exits, it's been garbage collected by Python and it's no longer doing anything. What we can also do is open Kedro Viz at this time. And if I bring it into screen, what you'll see is a very boring pipeline. It's really not doing a lot. They're completely parallel. They're not really intersecting, but it is a valid pipeline. Okay, let me get out of that. Now, if we bring in these catalog entries, so they didn't exist before, but essentially now we have keys for these data sets. They're going to go into the data folder in the intermediate folder, because that's our place for typed data, which is Parquet dataset. And I go back to this view and I rerun the last command. So that node, that explicit node, you will now see that instead of writing a memory dataset, it read a CSV dataset, it saved a Parquet dataset, and in the data folder, in the intermediate folder, we have a new Parquet file, which is able to, which you can see is git ignored because it's gray. It's useless to look at. That's one thing you lose compared to something like CSV. But as a data engineer or a former data engineer, always a fan of Parquet. It's a adult data storage format. The quicker you can get out of CSV, the better. Cool. We even have that moment highlighted on why it's good to do that. Okay. Now, in nodes.py, we need to bring this last node in. So the model input table is going to take shuttles, companies, and reviews and do a merge operation and delete some nulls. And that's going to make sure that everything is ready to be combined. In our pipeline definition, we're going to want to add an extra node, which is, let me format. On that, and let me import that node. Okay, so VS Code has kindly imported that for me. So now we have 3 nodes that are preprocess, and merge. That's essentially what we're going to do. I can also show you a little trick now. So if I do Kedro viz -- auto reload, I bring this window in. Okay, so now I have a pipeline that looks a little bit more meaningful. Let me move this to the left and this to the left. One of the fun things I can do in auto reload, and this is a really important development process, is I can see what it looks like if I remove this. So give it a second to notice that something has changed. And on the right-hand side, I will get my old pipeline back. But I can also show live that if I put this in a different place and remove the comments, Pedro doesn't care about the order in which the nodes are passed to the pipeline. The only thing Kedro cares about is how you get to the end of the pipeline, topologically speaking. So that means that the model input table will be the last thing built, irrelevant of the order that the nodes are passed to the pipeline object. I know that we've said this already in the other parts of the presentation, but I think it's a really neat thing to describe and reiterate that Kedro allows you to be fast at prototyping and get on with your job because you're no longer worried about this thing has to happen before this thing. All you're doing is saying, I want to do this, and that allows me to do that. Okay. My VS Code back. And continue with the tutorial. So if we were to run this, and actually we can, what this will do is it will run these first two nodes. It'll run this third node, which I could put in its original place just for readability. So I'm doing this only for humans, not for the computer. You'll see that this model input table at the end, that's never written to disk because, of course, it has no catalog entry. It's going to be a memory data set. So if I put that there, next time I run it, it will then generate this file. Okay, let's create our data science pipeline. Give it a second to think about things. Cool. So it's created those files. So in the source directory, in pipelines, we have our data processing section, but our data science section is new. Also going to do something new for the first time. I'm going to introduce parameters. So in our parameters folder, you'll see that we've created two that have been created for each pipeline. And parameters allow you to basically provide either hyperparameters or model metrics or something like the number of rows to accept, anything that you want to be parameterizable, but in a declarative way. And this goes back to that original point about separation of concerns. You don't necessarily want to hard code this in your business logic. By separating it from your Python code into this sort of declarative YAML mechanism, it means that you can think about things and test it in isolation, but also potentially a non-technical user can look at this file and know, oh, actually, we don't care about this feature being included in the model. I'm going to remove it. That is something that's possible. It is a user interface to an extent. But again, this is about encouraging people to make sure you don't hard code. That's why we're really here. So I'm going to copy this logic into my nodes file. Actually, I'm going to be smart and use this button rather than trying to do it the hard way. So in my data science nodes, I'm going to paste this in. And let's talk about what it's doing for a second. I have a split function, which is basically doing the train test split method straight from sklearn, not doing anything fancy. The only thing that is happening is that my target variable and my features in scope are purely driven by parameters that we pass in. The same thing for the test size and the initial random state seed. Those are not hard-coded. They are declaratively declared in this parameters file. It's also probably worth jumping into Kedro Ipython to show you how that all works. So if I do my catalog.list, you'll see I have more data sets now. I have my model input table and everything. I can also do something that's always fun. If you remember, I haven't actually run my model input table yet. I have a catalog entry, but if I run this, I'm actually going to get a file not found because I need to run the pipeline to create it. So that's something to keep an eye on later. But if you go back to the list, I can load my parameters like this. So I can say catalog.load parameters, and I get a big dictionary. Or I can be quite intentional about things, and I can say catalog.load. Let me just remind myself what they're all called. Catalog.load params model options dot features. Okay, and what that's done is it has realized that this nested key structure, I can say model options dot features, and I can be very intentional about what parameters I pass. Okay, back to Kedro world. I'm also, because I forgot to do it, I'm going to do a Kedro run, so I generate my model input table. So I think it will pop up here. Cool. So model input table is saved as a Parquet dataset, and it's popped up. So next time I do model input table.load, which is exactly what Kedro does behind the scenes, it will work. In my pipeline file, so data science.pipeline, I want to bring this in. Okay, what is it doing? I'm splitting data. I'm accepting my model input table and my model options. I'm going to expect my train and test data that has been split apart. I'm going to pass my train and test data independently to my train and evaluation. I'm going to create a regressor at this point and reuse that regressor there. And in the end, I'm going to have a node that I call evaluate model node. We could quickly jump to Kedro Viz to see what that looks like. What I'm trying to show you here is there's a really neat way of developing. But what visualizing it has shown me is I haven't registered the pipeline, which is functioning as expected. So if I go to register pipelines, I want to do something very similar here. So from Kedro tutorial.pipelines, import data science as DS. And I could do data science pipeline equals ds.create pipeline. And I could do something else. So I could do ds is data science pipeline. And I can actually start doing some algebra. So I can say my data science pipeline is those two pipelines. So my default pipeline is the combination of those two things. So this is an important point that you can build things independently and bring them together later. So if I Kedro Viz this, not sure why that's struggling. Never do a live demo, they say. I have a feeling our check to PyPy is maybe getting throttled. the output of this will actually be the combination of these two things. One of the things that's really exciting is that you can actually choose which Kedro, which explicitly named pipeline you want to run a couple of different ways. In Kedro Viz, there's a mechanism for viewing things you can choose which registered pipeline you want to do at the top left. I think it's working. For some reason, it's being very slow on my machine. Potentially all the streaming stuff is causing my little MacBook to struggle. I will give it one more minute. Okay, finally it's loaded. Okay, we have a more interesting pipeline to look at now. We have our data processing stuff that happens here, goes into the model input table, and that is used as the sort of joining moment between that pipeline and the pipeline below. I don't think we've had any layers. Kedro Viz allows you to sort of customize how you view it. There's also a light and dark mode. I'm dark mode for everything, so this is how I look at things. If we had any experiments, they would be there. You can also have a look at different nodes, so you can specify one, have a look at the code, always useful for describing what's going on. And what I found as a data engineer, this view was really great for explaining to non-technical stakeholders why my job was difficult. You know, get the data is sometimes email an Excel file, other times it's building a machine learning pipeline, and that one takes a bit longer. This node has a little yellow dot because it's a parameters node, or a node that accepts parameters. And if you wanted to, you can just inspect what's going on here. Oh, I actually had one more thing I wanted to show. Good, Chrome, reopen that. The last thing I wanted to show is those registered pipelines. If I wanted to just select them, I can. That also goes for how I want to run them. So if I just want to run the data science part, I think this will work. Because it has the model input table and the parameters ready to go. Those are the only real inputs of what we're doing. And it should run through, train the model. Don't actually call us out on the quality of the model, but you'll see how it works. Okay, we have about half an hour left. I've got to most of the tutorial that I wanted to show. You've seen how to build up a pipeline, how to combine them, some of the differences between a memory data set and a declared data set. Maybe it's a good time to talk about some of the other bits that maybe you cover later in the tutorial. So something worth highlighting in Kedro is there's a couple of different ways to run things. So by default, every time you do Kedro run, it picks what's called the sequential runner. And it will run each node one after the other in a mostly deterministic way, but each level of the topology will run at the same sequence. There are ways of running things in parallel. So parallel runner is really useful if you're staying in pure Python. So if you're doing things in pandas and other libraries that only live in Python, parallel runner will split isolated branches into their own multiprocessing processes. Python doesn't have true concurrency, so you can't use threads. However, when we're using something like Spark or Dask, you can use the thread runner. And because the execution is happening remotely, you don't run into any blocking that would cause that struggle. So the thread runner is for things like Spark and remote execution. Parallel runner is for pure Python work. You can also define your own runner. So something that we've seen people do are define like test runners that ensure everything always goes to memory data set. And that's been quite successful. We've done this pipeline slicing, but there's a lot more complexity you can add. You can say from this data set to that data set. You can say from this node to this node. And also when a pipeline fails, you get a little message like this, which says, maybe this is an old output. In the modern output, it will say to resume the pipeline from the point it failed. It will give you the little command that you have to type in to save you doing that. The rest of the tutorial talks about visualizing and also the fact we support plots in database. Sorry, in Kedro. So if you have a plotly data set, you can visualize it straight in Viz. And we have a quite representative project here in our demo site, which shows you some of the later features that we don't have time to go into in detail, but it's worth really highlighting today. So the first thing I'd like to highlight is you see that we have this super node. And that's because we have a namespace pipeline. And it's very similar to what we had in the demo before, but a namespace pipeline allows you to encapsulate all of that logic, and it really helps communicate what's going on in the pipeline. And as we'll see in the train evaluation section, by namespacing your pipelines, you can actually reuse them multiple times. So the code within these two blocks is identical. The only thing that is different is the parameters that we pass to it to make one generate a random forest model and one generate a linear regression model. This is super powerful, and we see lots of people say they're at a sales organization, have the same pipeline for one country and the same pipeline for another country, the only difference being parameterization. If you managed to cause a bug, let's ignore that. So I think that's everything I wanted to show you very quickly in the demo section. I'm going to stop sharing now and maybe jump into the Slido questions. So yeah, if you want to prioritize the questions that are coming through, please vote, add your votes shortly. Let me share this. Okay, so we have 3 questions. We do have half hour left, so if you have more questions, please keep them coming. I've read that Kedro cares about typing. Have you also considered ways of typing that encodes the columns on top of the data frame type? Yes, so good question. The easiest answer is to actually use a separate library. So it's not something that Kedro necessarily takes responsibility for because the nodes themselves are designed to be tested in a way that's agnostic of anything that's in them. That being said, the 2 libraries that I'm a big fan of are, of course, Great Expectations, which is very popular. Great Expectations is a serious framework and can be used for lots of purposes. In our hooks documentation, we talk about how you can integrate. The other thing I'll say is if you are only using pandas, the Pandera library is super easy to work. You can basically just decorate your functions and it will work out of the box. So it's something to keep in mind that it's not something that happens natively in Kedro, but there are 2 integrations via Great Expectations and Pandera that I recommend when you're using Kedro pipelines. You mentioned that functions should be pure. Pandas, modifiers, and passes pointers encourage explicitly copy, or does Kedro handle this? So no, Kedro doesn't handle this. I would encourage you to use the new .assign syntax. And I apologize, I haven't been sharing my screen. Just wait for the screen to be shared shortly. Okay, there we go. So in modern pandas, everything I've read from, I thought there was one of the maintainers, Mark Garcia, when I watched the last update by him, he was saying that the modern way of using pandas is use the .assign syntax. It's a bit different from the sort of square bracket syntax that people are familiar with, but the reason people like it going forward is that it is a lot more functional in style, and you create a new data frame at every step. And I think any opportunity you can be aspirationally functional in Python is a good way for writing well-tested or well-testable code. I agree you can be a bit naughty inside your Kedro nodes. We don't block you, nor do I think it's possible, but some of the guardrails we put in make it easier to not go too far off-piste. How do I run the same pipeline with multiple different parameters? So the word you are looking for is modular pipelines. That's the super node that we saw in the visualization demo briefly. I didn't go into it in the beginner training today because it's a lot to throw at you. But by adding namespaces, you can override parameters and reuse things. And this is a super powerful feature and one of our most exciting new additions to the library. Is there a Google Sheet dataset? Today, I don't think so. I have answered this question on Discord. There is a very, if you Google Python pandas Google Sheet, there is a Medium post that gives you the mechanism for doing so and loading it into pandas. Writing a Kedro wrapper for that is really straightforward. So we haven't actually got it in the library today. If you ever needed to define a custom one, it should take you 20 minutes, I think. If you do ever make one and you fancy contributing it back to the library, we would love that. And I will send you a sticker, maybe a hoodie. So please let me know. OK. How do we handle outputs during node execution? For example, if a node is creating some plot in JPEG and PNG format, how can it be saved in disk? So the way you do it is in your node, it accepts whatever information, but it returns, in this example, say you return two references to the same object. So you just return the same object twice in your function. That being said, in your pipeline definition, you can map those return statements to two different catalog entries. So you could have output JPEG, output PNG, and it will be saved twice. You can, if in the pipeline syntax, everything we did today is based on positionally mapping arguments. You can also keyword map. So if you wanted to provide a dictionary, you can map to the function return to the catalog entry also very easily. So what is the value of Kedro over tools like Prefect and Airflow? I did try to cover this at the beginning, but it's an important point and it's a subtle point. Kedro is about pipeline authoring. We want to encourage the rapid team collaborative situation that you get in notebooks, but encouraging you to use an IDE to follow software engineering best practice, to build well-tested pipelines that get you to the finished article that can be deployed and orchestrated in something like Prefect and Airflow. We have a native plugin for converting a Kedro project to Airflow, which was co-developed by the folks at Astronomer. And we have a guide on our docs on how to leverage Prefect for this purpose as well. So we'd like to stand behind the claim that your development velocity of getting to the finished article of the model you're building or the pipeline you're building will be faster and better written in Kedro. And then once you're at that point that you're happy with it, then it's time to leave Kedro and get into the orchestration world. Can you have a pipeline-specific data catalog? So, good question. The catalog that we showed today, you can actually split into many files. So, in terms of managing your catalogs, in order to make them clearer for humans to read, they don't have to live in the same file. They just have to be in a folder called catalog or have catalog in their name. And when you need to reference them, all that matters is that the names are unique across all catalogs. I guess pipeline specific is a bit of a funny question. I don't entirely know what that means. If you want to jump on our Discord, I'm happy to answer that as a more detailed one if we didn't already. Global credentials, very good question. So I think in truth, our credentials mechanism at the moment is designed to give people with zero infrastructure something that works. So if I'm honest, I think the best way to handle credentials is actually outside of Kedro. You know, if you're talking about things like S3, the best way to do that is by IAM access instead of managing keys in your team's environments. So the credentials pattern is, and I think we'd admit this, is limited in its scope. It's designed to be the first thing that you have if you have nothing and no team behind you. So I noticed, Nick, you also have a similar question about using something like AWS Secrets Manager. That is something that I think we could look for. A couple of people have asked for that. There are other enterprise-like solutions like HashiCorp Vault that I think do a very similar thing. But then it comes back to that same question of should that be managed in the pipeline framework or should it be provisioned to the users using that pipeline framework? So it's more of a style thing depending on what organization you're working in and how it's set up. Again, that one's a more subtle point. Maybe if you were keen to discuss it, create a GitHub issue, jump on our Discord. I think there's a lot of good that can come out of that. Databricks for training, good question. So I don't know specifically about what you mean by the config folder. I don't know if that's a Databricks specific thing or you're talking about ours. The main point with Databricks at the moment is it's very possible to use Kedro with its code API. It's very possible to package a fully running Kedro project and put it in Databricks to run it there. In terms of live development on Databricks, we're actually waiting on them to announce or release. They've already announced it, release their IDE integration. They used to have something called Databricks Connect, but it has been deprecated for good security reasons. They've announced their new thing that's coming out early 2022. We're still waiting on that. The minute that announces, we'll update our docs and maybe provide some training. We're also going to be speaking at the Databricks Summit in the summer this year, where we'll basically show a best-in-class implementation of Kedro on Databricks. Hyperparameter tuning frameworks. I've got to say, I don't have a great deal of understanding of how something like Optuna works. I know some people internally have used the Hydra multi-runner. I don't know if that's a similar thing. I think you can set up Kedro to do that a couple of different ways. So you could either do that within a node or an entire pipeline is maybe a tuning run. Maybe another one for Discord. I'd love to talk to you about and understand how best that could work. My initial reaction is it should be possible. I just don't quite know how it works. So it's just one of those things we just need to think through. Very good question of when do you recommend to start using Kedro? I think I would encourage you to use it from the beginning. So I think a lot of organizations go through this pattern where they maybe think that you can go through the like scrappy prototyping stage at the beginning and then harden it for production. There's even roles for that. You can maybe hire data scientists to build the model, get it working, get the the R-squared scored or whatever metric you're tracking up and running, and then have an MLE, a machine learning engineer, to come in, and then harden that code. I think I would argue that is an anti-pattern that shouldn't be followed. I think you should design robust code from day one. And what we encourage with Kedro is we try to give you a framework that allows you to prototype and be free and get up and running quickly. But you are encouraged to separate your concerns. So your code has to live in one place and your configuration has to live in another. Your pipelines have to be isolated as pure Python functions. And these sort of things get you further on that journey at day one. There's probably a little bit of a penalty you take in velocity as you get up and running with the framework, but I think you will quickly get into a pattern where you know roughly what the nodes look like, and maybe you can just start with inputs and outputs and then fill the business logic in later. I also think you can use Kedro and Jupyter in conjunction. So once you have your data sets run and in the catalog, you can run Kedro Jupyter Notebook, just like I ran Kedro Ipython, load your catalog data, play around with it, and then convert that into a node. There's a very common pattern there. Again, really happy to talk more about that one. In general, I think there is maybe even some bits in the docs about that very topic. Does Kedro workflow respond most preprocessing engineers? Absolutely. So this is actually done via data sets. So what's really common for us, at least, is that the data engineering work maybe happens in Spark, and then the data science work happens in Pandas. So because Kedro is data set centric, what you find is that once you set up your Spark configuration, all you have to do is declare Spark datasets or Delta table datasets, and they're able to be used in your nodes by your data engineering team. And then when your data science team pick it up, they can pick it up in pandas. And one of the great things that you have is that if you're using a storage format like Parquet or anything that's typed, so maybe SQL as well, what you could do is you could declare the same data set twice with the same name, but give a little flag to Kedro that you want to transcode between pandas and Spark. So if you search our docs for what's called transcoding, you can essentially reuse the same catalog name, but depending on who is consuming it, you get a different format. And then within your nodes, you can work in pandas or you can work in Spark, but you use that like persistent format like Parquet to split between the two. I think I'd like to answer that Kedro is used for both. I'm a data engineer by trade before I switched to the product world. And the work you do is very different. It's probably less parameterized. But as I said, you can split between something like Spark, which is more useful for data engineering than the pure Python world, very easily in Kedro. But what was a big accelerator for us internally is that because we were all on the same code base, you felt like more than one team. And you never had the it's the data science team's problem, it's the data engineer's problem. It became our problem. So I think it was a good accelerator for us internally to have everyone writing the same programming language and also using the same framework. I think there's lots to be said. The data engineering world is going through a bit of a transition as the SQL-based transformation engine is becoming a lot better. But I would say that Kedro is really well suited for any point that your work needs to go into Python world. And sometimes you do want the more expressive data engineering libraries in Python, like in Spark and etc., than you get in SQL. Okay, so we still have a couple of minutes left. Ooh, will there be an Epub reader? I don't think we would make one, but it should be very easy to read. I've never actually inspected the format, but it should be super easy to define. If you ever wanted coaching to do that, I would happily coach you through that on Discord. And if you felt it was useful, please contribute it back to the library. So, short answer: the core team isn't going to build that unless lots and lots of people say that would be useful. But the more important answer is it's very easy to do. Ooh, good question. Lots of votes for the Epub reader. Maybe I will have a thought on how to do that. Okay. In fact, let me make a note. Okay, are there any talks by other people? So the three most recent talks I would push people towards. Our tech lead, Ivan Danov, gave a talk at the MLOps community podcast about a couple of months ago that you can find on, and it's called 12-Factor Apps with Kedro, or 12-Factor Data Apps with Kedro. That was a real deep dive into why Kedro was designed that way, and basically the 2 minutes I spent on what 12-Factor App was at the beginning as an hour-long discussion. Then Kedro maintainer Lim, who spoke at EuroPython about mid last year, gave a really cool presentation about using Kedro, Airflow, Great Expectations all in one project, as well as giving a good overview on the journey to production and how we think best-in-class production could look using all those tools. And then the most niche and probably not, I think it falls into advanced design. At Packaging Con this year, which is a conference purely designed for packaging and build systems, one of our maintainers, Lorena, gave a amazing talk about how we're building the micro packaging module within Kedro. that is, again, an advanced part in Kedro that I only briefly mentioned and didn't get anywhere near showing. But the benefit for that is you're able to pull source code out of one Kedro project and reuse it in another. And the idea is that we really want to facilitate inner sourcing at our users' companies, where people say design a profiling pipeline, and you just reuse that everywhere, and it is maintained as its own product. Or you have an end-to-end modeling pipeline that has all of the abstractions that you find yourself using, and you can reuse that in different projects. You can use the namespacing pattern to reuse it within the same project. And that's really where the advanced part of Kedro and the main focus of our development for the last couple of years has been, where this concept of modular pipelines, namespacing, micro-packaging, they all fall under this umbrella of how do you reuse logic over and over again. Okay. So 10 minutes left. Any last questions? I'm keeping that Epub reader because 8 people voting is a good signal for me as a product manager. Okay. So unless there's any other questions in the last 10 seconds or so, I think we'll end it there. I just want to say thank you so much for coming. Hopefully this was useful. Again, if you have any other questions, raise a feature request or a discussion on GitHub, jump on our Discord, be part of the community. Hopefully you see the value of what we're trying to build here. And yeah, have a great day, everyone, wherever in the world you are. Thank you.